Okay, so let's suppose we have this vector. It starts at 1, 1 and ends at 2, 3. So it's got an initial point and a terminal point, and we want to put this in component form. So we have this vector PQ, and we want to put it in component form. So now this vector starts at 1, 1, and it goes over here to 2, 3. So to put it in component form, let's put that, when we put it in component form, let's just call this vector U. Okay. Well, component form would be this. We would take the x's, subtract the x's, the y's, subtract the y's. Whoops. And then what we get is a vector in component form. We get 1, 2. Okay. So there's our vector u. Now, what can we do with this? Well, one of the things we can do is we can find the magnitude of u. In other words, we can find the length of that vector. And remember, that's going to be the square root of 1 squared plus 2 squared. And that's going to be the square root of 5. So we've got the magnitude of the vector. Now, what else can we do? Well, we can find the direction angle of the vector. And remember, that's going to be theta is equal to inverse tangent of the y over the x. Okay, that's going to be the theta. Now remember, that's how we find theta if your vector has a terminal point in quadrant 1 or 4. Now if it has a terminal point in quadrant 2 or 3, then you have to add 180 to that. So you have to be careful about that. And if you're in radian mode, you would add pi to it. But this is approximately 63.434 degrees. That's what that is. So we've got the magnitude and we've got the direction of the vector. Now, one of the things we can do is we can start thinking about different forms to put this vector in. So we've got this vector 1, 2, and we could do this. We could say, well, I want to put this as a linear combination. So we could write that as 1, we got the I vector, little unit vector I, plus 2j. So that's a linear combination. Now we could talk about trig form. And trig form, remember, is going to be this. It's going to be the magnitude of u times the vector, cosine of theta, sine theta. Whoops, there we go. That's going to be, that's the trig form. Now we've got both of those. We got theta and we've got the magnitude. So in our example here, u is going to be the square root of 5 times cosine of 63.434 sine of 63.434. Okay, so that's the trig form. Now remember also, we talked about finding a unit vector in the direction of v. So let's suppose I want this vector, in the direction of u. This vector u has a magnitude of 5. Now, if we want to find a unit vector in the direction of u, we don't want to change the direction. We just want a vector that has a length of 1. In other words, we want a vector of magnitude 1. Well, the way we would do that is we recognize the magnitude is the square root of 5. So our unit vector, let me just call that. Let me just call this vector. I'll just call it A. This unit vector in the direction of u would be this. It would be u over the magnitude of u. So in other words, what we've got here is we've got this vector 1, 2 over the square root of 5. Now, we could go ahead and work that out, and that's going to be 1 over the square root of 5 and 2 over the square root of 5. There we go. So we've got that. Now, let's suppose we had another vector. Let's suppose we had another vector, and we'll call this vector v, and let's suppose this vector is 3, 5, something like that. And let's suppose we want to say, okay, I want to add u to v. So this is something else we have. We can add vectors too. So we've got a vector u, and we've got the vector v. We could just add the corresponding components. There's 3 and 1. 3 and 1, that's 4. And then 5 and 2, that's 7. So there we have it. So we added those vectors, and if it was subtraction, we would just subtract. Now we can also do scalar multiplication. So remember, we might have 2 times v. If we have 2 times v, well, that's going to be 2 times 3, 5. And that would be 6, 10. Yeah, like that. Okay, now one other thing. We have the dot product, u dot v. And this should get us ready for that, our first assignment here. But u dot v, we've got the u, which is 1, 2, and we're dotting that with v. So if we do u dot v, we just multiply corresponding parts together. 1 times 3 plus 2 times 5. And let's see what we get. We get 3 plus 10, and that'd be 13. Now notice the dot product is not a vector, it's a scalar. So when you perform this operation, the dot product, you get a scalar.